By using 3D scanning technology, building data can be collected much faster and more efficiently than with conventional methods. The technology enables a precise and comprehensive representation of a building's physical features in the shortest possible time. A 3D scan is a process in which an object or environment is captured in 3 dimensions using laser technology or other imaging processes. In the process, a large number of measurement points are captured, which are combined to form a detailed point cloud. Various information can be extracted from a 3D scan, such as a 2D map that presents an uncomplicated representation of the scanned object, highlighting room dimensions and pathways. Furthermore, 3D scanning enables the creation of virtual tours and provides precise measurements of distances, sizes, and volumes. Another advantage is that each component in the point cloud corresponds precisely to its real-world location, facilitating the management of materials and components inventory. The use of image recognition and AI-based algorithms in conjunction with 3D points clouds provides the ability to automatically recognize and extract individual building elements or components. In this way, architects, engineers, and construction professionals can quickly and easily create an inventory of building components. Overall, 3D scan can add tremendous value to digital deconstruction by combining precision, efficiency, and visualization.
I am Jean-Yves Marie, the co-founder of BIM-Y, and we are specialized in the creation of digital twins. We have integrated the DDC digital deconstruction as an expert and specialist in 3D scanning. During this project, we scanned several buildings in France, the Netherlands and Luxembourg, including the train station at Ettelbruck, which has been deconstructed now. We scanned the station in 2 phases because there were people who lived inside the station. So we had to proceed in 2 phases, and we discovered that there were unlit cellars under the station. So we brought back some light, we scanned in the dark, and finally we scanned with the people around us, and everything went well. Within a few hours we had finished scanning the station and the platforms of the station. Afterwards, we gave the 3D scan to the next team to realize the 3D model and to realize the assessment of deconstruction and reuse of materials. In the future, what we have seen after 3 years working on the topic of deconstruction is that we need a lot of inventory to make an inventory of the elements, to make an inventory of the new buildings, and that the technical documentation was not complete enough to obtain this type of information. So we developed and progressively developed models of artificial intelligence that allow us to recognize objects through our 3D scan. And the next step will be to develop more and more precise models to recognize lamps, the types of lamps, even the materials. Is it plaster? Is it wood? And also calculate. Nowadays we make a digital inventory and a unitary digital inventory in fact. And the idea is to calculate surfaces, because when you inventory the soils, well, we quantify them in surface. So that's the future for us, is rather the management of these data and the creation of these inventories through our images and through our 3D scans. Hello and welcome to Ettelbruck Station, the 3rd site pilot of the Interreg project Digital Deconstruction. Today we're capturing the 3D scan of the entire building for a future demolition in 1 year, 1 year and a half. In parallel, an inventory is done manually to make the comparison. So we captured the scan in about 2 hours and we were able to scan public spaces, the private spaces, the offices, the exterior, the platforms, and the entire facade. I am Guillaume Dubois, Civil Engineering Engineer at the Schroeder and Associés Engineering Office, also head of a unit called Special Construction Works, which deals with all the somewhat out of the ordinary projects. It's an exercise that is a little bit theoretical. We use a model that was created from the 3D scan, and then some elements were identified with different colors depending on their reuse potential. For us, it is then a game to navigate inside the model and to discover what are the different elements that will be identified as reusable and which will be visualized in green. Then we have to compare these elements to our expertise, our knowledge developed on other projects, where we have already encountered this type of element, and then we can confirm that it is an element that is reusable. So this is a very theoretical exercise. Actually, it may seem very theoretical, but in reality it is a practical purpose, as we want to be able to identify these elements, to find them inside the building, to dismantle them, and, at the end, to be able to reuse them. We are finally on the site of the Ettelbruck station, the traveller building station. It is a building that has a certain historical value, an old building which is quite beautiful. But in the context of the large Ettelbruck multimodal project, the CFL, the owner, decided to demolish the building and replace it. Consequently, there will be a new traveller building that will be integrated into a larger project. We were in charge of the pre-demolition audit for the deconstruction project. We came to collect data on site. We had old scanned plans, not very exact as we could see on site. There were transformations. There were also tenants who had reconstructed in their own way. We were able to access different places, collect different information, but it's still very manual. We do our traditional method. That means technicians who know how to recognize the different materials and who make this inventory. We localize on plans, we retrace all the plans. It's a certain time, but it's the only way to have valuable information to give to entrepreneurs who will bid for the deconstruction. We will be able to compare here with the 3D scan since BIMY came, and we will be able to analyze the time required according to the traditional method, the time required with the 3D scan and the interpretation that BIMY is working on, and to be able to put on the table what the DDC project will bring. I am very confident that we will have at short term an automation that allows us to save a lot of time, because currently it is very manual and sometimes very tedious. In a building like here, a medium-sized building which corresponds well to what we are used to work on, we will be able to compare these two methods. Then in parallel, there were all the pollutants studies that are done regarding asbestos and the other pollutants products. We proceed all the time in the same way with the same control offices. We have our habits, we work well together. That allows us to have complete projects. All the information is there to work correctly. And here, with all of this, we are going to recover as much as possible and see what we can do.
Show you a quick overview of the key functionalities of the web application delivered as part of the Digital Deconstruction project. To find out more about the project, you can visit the official DDC website. Let's begin. When accessing the link, I am directed to the home page. I will now log in. Now I am able to see all the projects that I have access to. We are going to have a look at the Ettelbruck train station project in Luxembourg. Once the project is loaded, you will be able to see some basic details identifying this project, as well as its cover photo. We are also presented with several tabs at the top: Participants, Locations, Documents, 3D Scan, Reversible BIM, Inventory, and Analysis. The project's participants page shows you who has access to the currently loaded project and what their roles are. Let's quickly add a guest to our project. The next time Albus Dumbledore logs in, he should have access to this project. Within DDC, a project is structured spatially. This follows the Industry Foundation classes schema of concepts, where we can define a hierarchy of objects starting with the project at the top, followed by sites, the train station, building, levels or stories, and spaces. The concept of a space within a space is allowed. I'm going to add a subspace to main hall. I can now manage my spaces, stories and buildings, rename or remove them as I like. On the site level, we can integrate the OpenStreetMap coordinates. New sites can be added with the plus button on the right-hand side. On the Documents tab, we see again the spatial structure of the project. This allows us to manage project files at each location level. Let's quickly add a new photo to the main hall area. Currently, there are no documents at this location. This is now reflected on the locations tree and is visible at the top tables as well. I can then download, edit, or delete. On the 3D scan page, we have integrated an externally hosted point cloud directly into the dashboard. This allows quick navigation to the project's point cloud via so-called points of interest. These are specific points in 3D space, which might refer to a space or a building element, which are part of the inventory. Let's navigate to a new point of interest. Let's now activate the point cloud. The inclusion of 3D point cloud and photogrammetry is important to allow us in identifying elements for their reuse, their materials and other properties such as lengths, or for planning logistics, and all of this remotely.